Okay, so for this section, we need to choose one of these functions and then find their important values and the vertex, etc. From there. So I'm going to take you through each of them, just starting with the first one. This one, x minus 2 squared minus 1 is in vertex form. So since it's in vertex form, the critical values that we're going to be looking for are a, h, and k, which for this case, a would just be 1, h would be 2 because it's the opposite of what we see in the parentheses, and k will be negative 1. For the vertex in vertex form, the vertex is just hk, and so for this case it would be 2, negative 1. The axis of symmetry when we're in vertex form is x equals h, or for all of them it's x equals the x value of the vertex, so for this case it is 2. And for the y-intercept, it's going to be a point where x is 0, and we need to substitute in 0 to the function to find out what y is. So if we have x minus 2 squared minus 1, I substitute in 0. 0 minus 2 is negative 2. Negative 2 squared is 4. And 4 minus 1 is 3. So 0, 3 is going to be my y-intercept. Once I have all this information, I can put it on the graph. I know that my vertex is at the point 2, negative 1, which is right here. My y-intercept is at the point 0, 3, which is right here. My axis of symmetry is at the line x equals 2, which is right here. And then I just need to draw the curve that would go through these points. So it's going to look something like this. Now go ahead and pause the video if you want to choose this form, because I'm going to go and do the next couple forms here in a second. So pause the video before I erase and do the next form. Okay. For the next form, we have x squared minus 4x plus 3. This one is in standard form. For standard form, the critical values are a, b, and c. So for a, for this case would be 1, b would be negative 4, and c would be 3. To find the vertex for standard form is we're going to take negative b divided by 2 times a for the x value. So in this case, it's going to be negative 4 divided by 2 times 1. Negative 4 will give me a positive 4, and 2 times 1 is 2. So that gives me 4 divided by 2, which is 2, for the x value of the vertex. Then we need to substitute that back into the function to find the y value. So here I would have 2 squared minus 4 times 2 plus 3. 2 squared is 4. Negative 4 times 2 is negative 8, and plus 3. 4 minus 8 is negative 4, plus 3 would be negative 1. So 2, negative 1 would be the vertex. The axis of symmetry is, of course, x equals 2, because that's going to be the x value of the vertex. And the y-intercept is going to be the point where x is 0, and we substitute that back into the function. So here we would have 0 squared minus 4 times 0 plus 3. 0 squared is 0, minus 4 times 0 would be plus 0, plus 3. 0 plus 0 plus 3 is 3. And we could have also remembered that in standard form, the y-intercept is 0, c. and C was 3. So here, once we have our vertex, our y-intercept, and our axis of symmetry, we can put those on the graph. Oops, looks like I didn't quite erase down here. We have our vertex at the point 2, -1. We have our y-intercept at 0, 3. We have our axis of symmetry at x equals 2. And we draw the curve that goes through these points. What you may notice is that we get the same vertex, the same axis of symmetry, the same y-intercept, and therefore the same graph as we had from the other function, the other form that this function was in. So this is actually the same function, it's just a different form. So this is why you don't need to do all three of them. They are just 3 different versions of the same form, but I will go through the last one if you would like to see it for more practice. So again, make sure you pause the video before I erase and go on to the next form. Okay, so the final form of this function is x minus 1 times x minus 3, x minus 1 times x minus 3. This one is in intercept form. For intercept form, the critical values are a, p, and q. With this one again, a is going to be 1, p will be -1, and q, sorry, not -1, because what's on the inside of the parentheses we take the opposite of. So if we see x minus 1, this will be a +1. If we see x minus 3, this will be a +3. The vertex in intercept form is, we're going to take p plus q divided by 2 to get the x value. So in this case, it would be 1 plus 3 divided by 2, which 1 plus 3 is 4. 4 divided by 2 is 2. So the x value of my vertex is, again, 2. We substitute that back into the function to find the y value. Here we would get 2 minus 1 times 2 minus 3. 2 minus 1 is 1. 2 minus 3 is -1. 1 times -1 is -1. So once again, our vertex is 2, -1, which gives us our axis of symmetry is x equals 2, because our axis of symmetry is always the same as our x value of our vertex. The y-intercept is always the point where x is 0, and we need to substitute back into the function to find it. So we have 0 minus 1 times 0 minus 3. 0 minus 1 is -1. 0 minus -3 is -3. -1 times -3 is +3. So the y-intercept is 0, +3. Once again, the vertex at 2, -1. Axis of symmetry at x equals 2. Y-intercept at 0, 3. And we draw the curve that goes through those points. So as you can see, we got the same vertex, same axis of symmetry, same y-intercept, no matter what method we chose. You can use these to kind of check your answers and make sure you've done them correctly. Use a different form and solve it just to make sure that you've done everything correct. You should get the same answers. Right, and that is all that we need to do for this one. Hopefully this will help you to prepare for the test.